Hello, my name is William. I am part of the product marketing team at GitLab. And in this video, I'd like to talk to you about the modern infrastructure automation practice of GitOps. I'll talk about what GitOps is, why GitOps is important, and what you can do to begin adopting GitOps in your organization. Before we dive into GitOps, let's just take a look at what has set the stage for GitOps, which is the fact that the modern landscape for software development is changing. As always, software development is very dynamic. As new technologies and practices emerge, the world changes, and we need to adapt to those changes. So take a look at what sets the stage for GitOps. Let's just take a look at some of the ways that software development has evolved recently. Beginning with Waterfall, Waterfall was really delivering software like it was hardware, like you're packaging a box, putting it on a conveyor belt, and shipping it out physically. There are a lot of challenges with doing waterfall, and unfortunately, many teams are still practicing waterfall. One of the main challenges is the cycles are so long, it's a long time before you get any feedback. You could even be writing software that nobody even wants. So in order to address these challenges, the software industry came up with agile software development. Now, there's a lot involved with agile, and there's a lot to debate and to like and to not like. But in a nutshell, Agile is a step forward because it introduced making smaller changes. So rather than these big, long cycles, you break that up into smaller iterations. And out of these smaller changes, all of a sudden you're getting code out faster and you're getting feedback sooner. So there's a lot of advantages. But the problem is when software development teams are sending code over the proverbial wall to operations teams to deploy and operate it, and they're making smaller changes, which means they're making more and they're sending over more, then the environment and the practices and the technology needs to change in order to adapt to the more code and the smaller changes. So this is where DevOps comes into play. DevOps is about software development teams and operations teams working together and engineering and automating their practices so that they can not only write code in small changes, but also test and deploy those small changes very, very rapidly. This is an amazing step forward and a wonderful software practice. But now in the modern environment, we're facing even more challenges where we need software applications to work at amazingly large web scale and deal with things like microservices, containerization, service mesh, and this modern world of Kubernetes and containers doing cloud native software development. What applications need to do is, as load comes on the application, they need to scale up the infrastructure that it's running on. And then when there's no load, it needs to scale down and do this all dynamically in a very, very complex way across many microservices. So in order to meet the operational needs, in order to address these modern operational challenges, this is where GitOps comes into play. As I mentioned, I'll talk about the what, the why, and the how of GitOps. So to start out, let's just talk about what is GitOps. GitOps is an operational framework, and it takes the DevOps best practices used for application development. These are things like version control, collaboration, compliance, and CI/CD, and it applies them to the realm of infrastructure automation. In a nutshell, GitOps has three main components. It equals infrastructure as code plus merge requests as your agent of change plus CI/CD automation. So what I'll do is quickly look at each of these components, infrastructure as code, merge request as a change agent, and CI/CD automation, and talk about what they are and how they fit into GitOps when you are practicing GitOps, how you use each of these components. So to start out, a major component of GitOps is having your environments stored as code in a Git repository. Now, here I use the term infrastructure as code, but this may not be relegated simply to infrastructure. Sometimes I might say X as code, or even just your environments in general, because this could be infrastructure, configuration, policy. This could be network configuration, or anything at all about your deployment environment where you need to run and operate software. Instead of having to manually configure that, you describe it in code so that it can be stored in Git version control. This is the core component of GitOps. Often this code can be declarative, which means you are declaring the eventual state that you want the environments to be in, and then your automation is going to reconcile whatever state your environments are in, the automation is going to shift it towards the source of truth. But some folks in some phases of GitOps are maybe using procedural code as well. But as we move forward, the very, very mature ones are usually doing some type of declarative code describing the desired state. Of course, this is stored in Git version control. Now, really, you could do GitOps using any version control, Mercurial or SVN or any number of version control systems. And you're going to get the benefit of using version control. But when you're doing GitOps, it's very critical to be using Git specifically, and more importantly, a Git management tool. We'll talk about that in just a moment. One of the benefits of using Git specifically is that you get to use all of the Git tooling as the UI into your system. So rather than having to have a GUI where each type of environment configuration is something new and something different to learn, rather, now all of a sudden you have a standardized set of tooling, everything from the command line to your IDE to a whole set of other tools that know and integrate with Git. You have a very well-known system, one that folks can teach you about. There's a lot of learning materials. There's all these advantages of using Git. And so that now becomes the user interface into changing your infrastructure and managing your infrastructure via Git. The next component, as I mentioned, and why it's important to use Git, is that merge requests become the agent of change. And at GitLab, we call these merge requests. In other systems like GitHub or Bitbucket, these are called pull requests. And the idea is this becomes the gating mechanism for any changes that are going to go live. This involves using a system where you have a branch, and that branch represents the state of a particular environment. So this could be your dev branch or your staging branch or your production branch. And let's say you have a production branch, that branch of code represents what you want deployed to production. And so anytime you want to make changes, you make a fork or make a feature branch or a patch branch. You do your changes there, and then when those changes get proposed to be merged back in via a request to merge or merge request, that then becomes the gate. This is where you can do code review. This is peer code review. This is where approvals can happen, security reviews. And this is also where you can manage compliance, for example, like mandating who has the ability to actually merge that code. Then that gates who can make production changes. So many people can propose changes, and you can still have compliance with very few people who can enact those changes. The last component here, which I've touched on a bit because they are all interrelated, is automated reconciliation using continuous integration and continuous delivery, CI/CD. And I call this a reconciliation loop because the idea with GitOps is that you are continually looking at the state that is running and your defined state. And if those are out of sync, you want your automation to shore those up. So in some ways of, if you were to start practicing GitOps, potentially you could run your CI/CD only when there's a merge request. Like I just talked about the CI/CD running when you merge new code in to, let's say, your production branch. But a more evolved or sophisticated mode would even be running that CI/CD automation at certain intervals, even when there are no code changes being merged in. And essentially what that's doing is that's watching your environment to make sure that it's always up to date with the latest changes. So this reconciler loop, it could be of different flavors. It could either be a pull or a push. Sometimes there's what we would call agentless. This is how GitLab CI/CD works. There's a lot of CI tools that do this. If you're using a tool like Spinnaker for CD, we'll talk about tooling a little bit more towards the end of the video. But the idea is your CI/CD system, when it gets changes from Git, it then pushes those into your environment. There are also systems that you might have an agent running within the environment, monitoring the environment. And when it notices it's looking out at your Git repository, and when it notices changes in the Git repository, it's going to go out and pull those changes in. And both can be used for GitOps. The idea here is that when the infrastructure state is out of sync, the CI/CD updates the infrastructure to match the definition that's in Git. And of course, all changes are implemented in this automated fashion. So when you're practicing GitOps, you don't do any manual changes to production. This is a fully automated CD. This is what the flow might look like for an operations engineer that is practicing GitOps. They might start with an issue. Let's say there's a bug to fix or a new feature or a new request that comes in. And in that issue, they can make sure that they understand everything that's needed and collaborate on that. And then they want to create the merge request, which starts a new branch away from the main branch. In this case, we've called it feature, but you could call that side branch a patch or anything that you had a new proposal. And you commit your changes to the new branch. While you're committing those changes, the CI automation runs automated testing. So you can get a lot of code quality and security and bugs out of the way just via that automated testing. Next up is the concept of a review app. Now, you may or may not use review apps. With review apps, essentially what you have is within that feature branch, you then spin up a production-like environment to test those changes out in a running production-like environment. This is essentially like having a staging environment for every single branch proposal. This is nice because unlike having a singular staging environment where many people's changes that you're testing could conflict with each other, you can test each proposed change in isolation. And that's a nice component. So whether you're using a shared staging environment or staging environments on every branch, which we call review apps, those are different ways to handle it and have some benefits for each one, some pros and cons. Within that, you can then do peer review and discussion on the merge request, the collaboration. And if you have the review app staging environment, you can even review the changes live. That can be a great part of the collaboration system. And then you want a Git management system that allows you to have approvals to manage your compliance. So for example, you might need somebody from a member of your security team to approve, or you might need a member from the operations team and a member from the development team and a member from security. These types of things so that changes can meet your compliance. Finally, when the merge request is merged, it closes out the issue and the main production pipeline runs, which is going to enact those changes to the production environment. And once it's running, you then monitor that environment or monitor the applications running in the environment. So this flow looks very, very similar to what a GitLab flow or a Git flow would look like for a software developer just practicing DevOps with their application development. The only difference is this is proposing infrastructure changes for an operations engineer. So GitOps and infrastructure as code are related terms. I would even think of GitOps as encompassing many things, and a component of that is infrastructure as code. As I just talked about earlier, infrastructure as code plus merge request plus CI/CD equals GitOps. Let's talk a little bit more about how these terms are related to each other. With GitOps, of course, you have code. It's going to be stored in Git. When you're using infrastructure as code, it may or may not even be under version control. You could be defining your environments in code and using a tool that allows you to define your environments via code, but that doesn't necessarily mean you're versioning them. It could be living in a flat text file somewhere. And that's still infrastructure as code, but it's not GitOps. Similarly, using merge requests as your agent of change, if you're not version controlling, or maybe even if you are version controlling, you may or may not have to go through any kind of review or approval or code quality process and collaboration. So if with infrastructure as code, there's no mandate to use merge requests, but doing this in the practice of GitOps gets you all these benefits. And then similarly, with GitOps, infrastructure updates are automated, whereas when you're doing infrastructure as code, it may or may not be automated. Perhaps you're using a command line tool to run and update your infrastructure. And so it's not necessarily automated. It could be a manual process. But if you look at how these are related, essentially GitOps is infrastructure as code done right. If you're practicing infrastructure as code and you are doing all of the best practices, then that starts to look a lot like GitOps. So now that we've defined what GitOps is, let's talk about what some of these benefits are. Why is GitOps important, and what value is it going to bring to your organization, or what value does it bring to organizations that are practicing it? So I'll talk about these benefits in the context of using different components. So the first is the benefits of storing your definitions in code. So when you're doing infrastructure as code or X as code, you automatically get some benefits. One is self-documenting environments. If your environments are configured manually via a GUI-based tool, then you need to have the documentation for that completely separate. This means if someone else wants to come along and understand what's happening, hopefully the documentation is up to date. And if you're trying to do any type of collaboration, or even if you just want to remind yourself, what did you do last week or last year? Sometimes that can be tricky depending on how good your documentation was. Whereas if all of your environments and your infrastructure are defined as code, now you can just go and read and see what's happening. And to some degree, it's self-documenting. This doesn't completely alleviate the need to do any documentation whatsoever. It's always a best practice to do additional documentation to yourself and to your colleagues and to future colleagues. I always think that if you document things like as though you're documenting it for somebody who's coming along and doesn't know anything at all, a new member of the team, you then also end up documenting for yourself as well. Like I had mentioned, maybe it's next week, you completely forgot. So you're being kind to your new team members, your existing team members, and your future self by keeping good documentation. And even if you're doing infrastructure as code, that documentation might be, let's say, in a README within the same repository. So there are even some benefits there. But to a large degree, you get these self-document environments. You also then, as I'm already alluding to, get shared knowledge among your teams. Let's say you have a team in Brazil and they have built out the set of infrastructure and running an application, and things are going really, really well. You want to proliferate those best practices that team has come up with over to your team in the UK. Well, now you can share that knowledge because you can say, here's the code repository defining everything that we've done. Essentially, this is the value of open source when you share your code with the world and anybody can see what's happening, or in this case, inner source. The same way you can inner source your application code, you can inner source your operations code and your infrastructure as code. And that way it's easy to share knowledge between teams. Even once it gets over to the UK, changes that they make and adapt and improvements that are made can easily be shared back because it's all defined in code. Finally, this makes it much, much easier to then start to be able to duplicate your environments. Let's say that the UK team wanted to completely just take the environment that the Brazil team came up with and just deploy it as is, or enact it and create it as is. Well, that can be done when you have infrastructure as code. If everything's defined as code, now you can just take that definition and clone it as many times as you need. This might be to set up a similar or the same environment in different regions, or to make different instances. This might be so that stage and prod look the same or feel the same. Or this might be a case where there's a problem or a bug and your environment has collapsed and you need to recreate it. Well, you can do that if your definition is stored in code. The next set of benefits come when it's not just stored as a code definition, but you have it under version control to be able to roll back and roll forward within history. So the first thing, a benefit you can get out of this is you can begin to, in some instances, couple the application version to an infrastructure version, or at least set a dependency between those two. They don't necessarily need to be tightly coupled. In fact, I'll talk later on about how it's even better if these things are loosely coupled or completely separate. But if they're both versioned and you can determine that this version of the application needs a certain version of the infrastructure, you can get some benefits out of this. For example, let's say you have an application and in the first version, you got it out quickly, you got it out to your users, you're testing, but there's a rather large memory leak. And so in order to run in production, it needs a lot of memory dedicated to this application to be running. Well, in the next iteration cycle, you fix the memory leak and maybe some other bugs, and you get that out there. And so in order to save money, you now cull down your environment and you're using a lot less memory. Well, now all of a sudden you figure out that there is a bug in the code. Something is not working right. It's not the right user experience. And you need to roll the code back to the previous version. Well, the problem with that is that that previous version of the code still had this memory leak. It still used up all of this memory. And if you deploy that into this environment that has just this very small amount of memory, is designed for a much more optimized set of code, the application is just going to fall over on itself. Whereas if your environment is also defined as code, now you can roll back that environment to the previous version as well. That spins up the additional resources needed to handle that particular version. It's a really powerful benefit. Another benefit is not related to application code at all, but let's just say your infrastructure itself is misconfigured. There is a bug or a problem within your infrastructure definition. If it's in version control, now it makes it easy to roll back to the last known good configuration. When you detect a problem, instead of having to wait until you have done all of your forensics and troubleshooting to uncover what's wrong, you can roll back to the last known good configuration, have things up and running quickly, and then do your forensics. It's a very powerful mechanism. And of course, when you're doing this, this lowers your mean time to recovery. We know from organizations like DORA that when you are practicing these kinds of DevOps best practices, and again, GitOps is like doing DevOps for infrastructure, that there are positive business outcomes that come from practicing DevOps. So businesses tend to get larger market share, tend to grow revenue faster, et cetera, have all of these positive business outcomes when they're practicing good DevOps and good software development. So we know that there's a direct correlation between positive business outcomes and lower mean time to recovery. So having your infrastructure definitions under version control and being able to roll back to that last known good configuration lowers your time to recovery when things go wrong and you need to sort things out. The next bit of benefits is the automation benefits. So when you are automating CI/CD, you via CI/CD, you get some benefits. So the first is that you can deploy faster more often. This is really the value if you have application code that is being shipped and iterated on very quickly and is able to be deployed very, very quickly. Well, you want your environments themselves to be able to be iterated on very, very quickly, and that's what GitOps gives you. Similarly, and I've alluded to this earlier in the video, you start to be able to address the problem of configuration drift. And so when your environment is not configured per your definition, when that automation loop runs or the next time CI/CD runs, it's going to update with your it's going to update with the source of truth that is stored in Git. And so any misconfiguration or any drift away from what's canonical is going to be set to the canonical source of truth via your GitOps automation. Finally, and this is what I find to be the benefit that I hear the most about, or brings even the most value, especially to large organizations, is that GitOps allows them to be secure and compliant. So one of the benefits here is the way that you are granting permissions to your environment. Without GitOps, you tend to have a lot of different environments, and everybody who needs access to do anything at all to those environments needs direct access to those environments. So this is a lot of permissions to manage, and it's very, very hard to keep that group of people small in order to meet, certain regulatory compliance or internal compliance standards. Whereas if everything is stored in Git version control, all of a sudden now anybody can propose a change, but you can lock down the permissions of the people who actually have permission to merge to a branch. You can make that a very, very small group and stay compliant. Similarly, auditing becomes a lot easier when your Git log of all of the changes that were made becomes that log of what the changes were. In a manually configured environment where or when you have manually configured your environments, when that's what you have to contend with, then you tend to have to go around to a lot of different places and potentially different tools and gather a lot of information in order to do your auditing. Whereas if everything is stored in one place, you have a Git repository, and these are the changes that have been done to this environment. You have a nice clean log in the Git history. This is very, very powerful that can speed up your auditing process immensely. And of course, you can comply with any type of change process rather than having to be in the old world of getting into a meeting with people to discuss the change process. That's very, very heavyweight, that's very, very slow. Now you can have very, very quick changes. Anybody can propose a change quickly. It can be reviewed very, very quickly because it's in code, and it can be enacted very, very quickly. And at the same time, you can have all of that speed and still be compliant and still have a small set and a defined set of people who are able to make those changes and have all of your approvals in place as well. So these are just some of the benefits of GitOps. There are many, but these are some of the big ones that I hear about often. So with that, we talked about what GitOps is, why it's important. Let's talk a little bit about how can you start doing GitOps? What does a GitOps team look like? What are the technologies involved? And what are some of the challenges that you might face when you start to go and adopt GitOps, or when you start to deepen your GitOps practice? Well, to start out, let's look at team structure. Now, there are an infinite number of configurations for how to structure your teams and your org chart. This is one that I've seen the most common. So there are a lot of different ways to do this, but of those, the commonalities that seem to come from the successful teams, this is a representation of that. And there's usually 3 components with 2 to 3 sets of teams. So you would have your development teams represented by these vertical slices, and each of these slices could represent, let's say, a feature team or a product team working on a particular product, or in this case, a microservice. So each of these teams owns a single microservice or perhaps a set of services. And those services or applications are delivered to production on a platform. So the deployment platform is run and managed by the platform operations team. And the operations team is going to be responsible for the clusters. And in this case, it's Kubernetes. You can do GitOps without Kubernetes. You can do GitOps. You can do all of these things. You can have your infrastructure as code. You can use merge requests as your change agent. You can apply your changes via automation. And you can do that all without doing containerized Kubernetes applications. But what we've seen is that GitOps has taken off the most within the cloud native community, and that the very, very mature GitOps practitioners are using Kubernetes. So in this case, the platform operations teams, they're the ones that are managing the clusters, creating, spinning up, managing those clusters, and serving that platform up to the dev teams. There also is an optional component of an infrastructure team. So at some point, there needs to be a server somewhere. It can't just be turtles all the way down. It's got to be running on a server somewhere. That's either a server in your on-premises data center or a server managed by, usually a hypercloud, AWS or Google or Azure, et cetera. And then you may have an infrastructure team that's either managing your physical infrastructure, or they're managing a set of virtual machines and configuration and network within a cloud provider like AWS. And so it could be within your organization that your platform engineering team owns not only the clusters, but they also do all the infrastructure work as well. I've also seen organizations where they have a dedicated infrastructure team and a separate platform operations team that just manages that middle layer. Within the dev service teams, what I've seen is a best practice of having those as cross-functional DevOps teams. These aren't siloed, all the developers are here, all the quality people are here, all the operation, the people who operate the application over here. But those people actually sit together and work together, or virtually sit together in the case of remote work. Those folks are a part of a cross-functional team. And the idea here is also that there's not a complete separation of concerns. So it's not like you have developers who are doing 100% of the software development, and then they chuck it over a fence to, let's say, a site reliability engineer to operate and monitor that application when it's running. The split here is kind of like a Pareto principle of an 80-20. So the developers are usually 80% software development, but they understand how the application operates. They understand how to monitor the application. They can own the pager. If their service goes down, they're the one that fixes it. They not only develop it, but the team owns the running of that service as well. So it's 80-20 development operations for the devs. And the SREs would be like 20%. They understand how the application is built. They know the software development part of it, but their primary concern is the operation of that service. So that's the cross-functional DevOps team. You have the platform team. They own the clusters. If the environments go down or if the cluster goes down, that's the platform operations team that gets paged there. So these are the separations of concerns. And this is how this tends to work in larger organizations that gain some efficiencies from doing this. If you're on a small team or a single developer, you might just be a single developer and you're just doing all of the GitOps yourself. And the person who's approving is yourself. But if you're on a team of 2 or more, using GitOps gets you this collaboration benefits. And even as your teams grow, there might just be 2 or 3 of you and you're doing everything across the stack, but you can still practice GitOps. So it's a little bit about the team structure. Let's now take a look at some of the technologies that are involved. What are the tools or the technologies and the capabilities that you need in order to do GitOps? So of course you need a Git repository, and I've talked about that. But in addition to that Git repository, you really need a Git management tool. If you just have a vanilla Git server that you've spun up yourself, but it doesn't have the ability to do merge requests or pull requests, then you aren't getting the full benefits of GitOps. So you could potentially do that in a nascent or an immature version of GitOps as you're getting started, which would be perfectly fine. But as you move into maturity, adopting a Git management tool is going to give you this powerful pull request, merge request capability. Next up, I've already mentioned talking about you need a continuous integration tool. This will allow you to automate any of your testing and quality checks, builds, etc. Do all of that in an automated fashion with continuous integration. Then core and critical to practicing GitOps is the continuous delivery tool. So this is not only automating your build and test, but automating the deployment itself. And this is not just automating the deployment of the application code, but automating the application of the infrastructure code or the enacting of the infrastructure code. So when you are deploying or creating or changing your infrastructure, those changes happen in an automated fashion. Those are delivered continuously via continuous delivery. And there's a lot of different tools here. They could be, as I mentioned, pull-based tools like GitLab and Spinnaker, or push-based tools, or it could be a pull-based tool like Weaveworks Flux, which has an agent that runs within the Kubernetes cluster, is known as a Kubernetes operator. Next up, if you are doing Kubernetes development or containerized development, you're going to need a container registry in order to store your containerized applications. Now, also on the list here is the configuration managers. This is the traditional way to do infrastructure as code using tools like Chef and Puppet and Ansible, Salt, etc. These are the traditional infrastructure as code tools that really started when DevOps started. And in some ways, when you start containerizing your applications, all of your server definition is within your Docker file, and that alleviates some or all of the need for any type of configuration manager. So in some cases, you may not need a configuration management tool, but what we find is for many folks, they're still using a tool like Ansible to do configuration management, even if it's just at the infrastructure layer where they are dealing with servers that need to be configured or virtual machines, etc. The nodes for the cluster, so to speak. In addition to this, you not only need to have your configuration, but your provisioning as well, what's actually going to go out and enact those changes, particularly within a cloud environment. What we see folks is when they're completely on premises, they might only use configuration management, but once they start moving to the cloud, then tools like Terraform and Pulumi and AWS CloudFormation become very, very critical. And folks start adopting Terraform when they're moving to the cloud, because this is not just about provisioning the virtual machines themselves and saying, okay, I need this type of virtual machine with this size and et cetera, but also the network, firewall, any type of configuration or any type of provisioning for the environment. Anything that you need in that environment, I need to spin up this environment. Please give it to me, cloud provider. You need to have a provisioning tool, Terraform, Pulumi, et cetera. And of course, we've talked a lot about Kubernetes. Kubernetes is not required to do GitOps, but what we find is that as you grow in maturity, as in your DevOps and your GitOps practices, that folks tend to start adopting cloud native software development patterns, start containerizing their applications. Not everybody. You might be doing software that runs on embedded systems and it doesn't make sense to containerize that. But even if you're doing embedded systems, I spoke with one of the engineers, who does embedded systems within smart cars. And even though they're doing embedded systems, they sure have a heck of a lot of web services that they still communicate to for a lot of things. And so they're containerizing all of those web services. So may or may not have Kubernetes for various purposes. With that, having looked at the technology and the tools, let's talk a little bit as we go to wrap it up, what some of the challenges you might face as you go to adopt GitOps within your context. So the first challenge, whenever you are looking to change anything within your organization, the first challenge is always cultural. There are hearts and minds and practices that need to change along with the technology. People everywhere are always used to doing the thing that they're used to doing. They're used to doing what they're used to doing, and change is hard for anybody. And so helping folks understand the benefits, helping folks see why it's good for them, can help them see how those changes are going to be made. One of the practices that we see very successful, whether it's just adopting GitOps or just adopting DevOps or even in an agile transformation, is when there tends to be one team that I call the lighthouse team. When there's one team that can start adopting it, and then other folks in the organization can see how they're running and how that's benefiting, then they start to buy into it more because it's proven the point. Whereas before they didn't know if it was going to work or not. So the idea here is that operations engineers, in order to do GitOps, are going to need to adopt a developer-centric view of their work. And operations engineers may not want to do that. Many do. Many are, operations people are learning software development and thinking about their jobs in an engineering way, and automation is all very exciting to them. But some folks are not very excited about that, and they've been doing this for a long time. And so one of the challenges you may just need to face is that GitOps really is a developer-centric workflow. And if you're a developer, GitOps is an amazing way to run your infrastructure because it leverages everything you're already doing and everything you already know. If you are an operations engineer, this may be completely new to you. And so it requires learning some new skills and some new practices. Next is the next barrier that you may face is that you need a sophisticated level of deployment automation. I mentioned this earlier. This is about not just automating through CI, but also very sophisticated CD. And your organization or your team just may not be there, and that's okay. You don't have to be all the way doing 100% GitOps for everything to get some of the benefits from doing some GitOps, right? So you can even just start out by using infrastructure as code. You can even then start out by just versioning that. Then you can start to adopt merge requests. And so there are steps along the way before you get to a very, very sophisticated level of deployment automation and using a very sophisticated CD tool, which if you have an existing application, an existing technology set, and a large team, that can take a lot of time to bring all those people along to get to a very sophisticated level. Finally, not everything should be GitOps. Not all operations belong in Git. These are a few that I can think of that may or may not work the best if they're defined as code. You can think of something like observability tools. Your logging, your tracing, your monitoring. Um, there's a lot to be done, and there are very sophisticated tools for that. And if you try to distill that all down into Git and require a merge request for every single change, it's a pretty heavyweight process for every single change that would need to be made. I don't think for observability tools, we're going to see them moving lock, stock, and barrel into Git anytime soon. That doesn't seem to make sense. Another example of this might be feature flags. For example, if you are doing progressive delivery and you are feature flagging your application so that it's serving different code to different users at different times under different circumstances, this is a wonderful software development practice that lets you deploy under less risk and it lets you test changes. But it doesn't really make sense to define that all in Git, or for every change to flipping a feature flag on or off, requiring a merge request. That, again, feels heavyweight. Finally, some type of operations practice like incident management, although certainly large components of managing incidents when your infrastructure is down or degraded, when there's a problem and you need to bring things back up, some components of that, having things that are written down in text-based or code-based format that can be versioned and shared, there's certainly going to be some benefits there, but there's a large component of incident management, a large part of that tool set that really just doesn't belong in Git and is a parallel practice alongside of GitOps that isn't necessarily, you're not going to GitOps and put all of your incident management into a Git repository. So those are just a few. There's probably more. If you can think of more, you can comment on the video or reach out to us on Twitter, but these are just some of the challenges. So with that, I want to thank you for hanging out for the video. We talked about what GitOps is, why GitOps is important, and how you can start adopting it. If this has been helpful or you learned something new, I'd love to hear from you. Like I said, please leave a comment on the video or reach out to GitLab or myself, the William Chia, on Twitter. And we'd love to just continue this conversation. GitOps is continually evolving. We're learning more and things are changing. And as those change, we at GitLab would love to collaborate with you and co-create with you this new, fun, exciting future. Thank you very much.